So guys, I am live. Make sure to join my live stream on my YouTube channel. The link is over here. Hello, 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 hello everyone. Hello, how is it going? Welcome to the channel. Welcome to the stream. So let me mute myself. Yeah. So I was trying to check if my audio is right or not. So it seems everything is good. Now let's move forward. I'll first introduce myself to you guys. So I am Ashish. The people who has already been following me for quite some time knows me well, and they're out of many people. Those are my friends, and other are my supporters. So what I am doing here. So I am here to start a series. Okay. It will be a multi-day live stream series where I will be making different we will be making different type of microcontroller development boards, or maybe a something very particular, okay, for our need requirement or for some project. So I have been trying to do this for a long time, and it is finally I'm finally going to start this series, and I hope I'll be very consistent on this. Okay. So to give you a background, okay, my full name is Ashish Jaiswal. I am a by profession I'm an electronic engineer. Okay, like I work as an electronic engineer in a company, but behind the scenes I am a very, big tech enthusiast and as well as hobbyist. Okay, so I try to make different projects. As you can see, there are couple of drones there. Okay, those are like FPV drones. I have couple of things over there, and I have a workbench right next to my this desk. Okay, I'll show you, and you will be able to see later during the series. But to give you an just example that yeah, I try to work on a lot of things by myself, as I don't have a background of an engineer. I have my graduation in Bachelor's of Information Technology, and my master's. I have did my master's in robotics. So the thing is, I when I became an electronics engineer, everyone will be thinking that you are uh, well, you have knowledge of electronics and whatnot. That is not entirely true, because I haven't taken a course, or you can say I haven't gone to like a college or a university just to get that particular diploma or degree. I did my bachelor's in IT, which helped me a lot in like, as there were there were subjects of digital electronics in my course, and some part of it was analog as well, but it wasn't as detailed as you get to learn in your like particular degree, right? So but I had a basic understanding how digital system works and whatnot. Like it wasn't as detailed as how UART communication happens, how I2C communication happens. Okay, it was just like ones and zeros through table and gate logic gates. Those were the things which I learned during my bachelor's in IT. That thing intrigued me, okay, so much that I started learning a lot of things by myself. I didn't enroll to any of the courses online. It was me and you can say Google. Okay, back in the days, like 4 years, 5 years ago, there wasn't AI platform where I can just drop in some text. Okay, explain me this concept or explain like how this work or anything. Back in the days, like 4 or 5 years ago, when I was learning things, it wasn't there. So for me, it was very difficult. Like you are already pursuing a career as an IT profession, and you are very much very interested in learning electronics, and not just electronics, it was hardware design as well. I know hardware design. Like if you can see, there's a like a very small 3D printer like right next to my whole um, TV case. Whatever you want to call this furniture, I like it is more overly like I'm using it for storing my stuff, like my hardware stuff and whatnot. So yeah, so I just don't have experience just in a single domain. I have experience in like 2 to 3 domains, but the thing is, I can't say that I'm a full professional person in that domain. I have knowledge, but that knowledge is so little to compare to other people who have been working into that domain, right? So yeah, so continuing the thingy, like the short story to introduce myself. Yeah, then I learned a lot of things by myself. Like, and a lot of people, what will do if they are trying to learn something, they just go in the market, they get a book or something, or go on YouTube to learn some concepts and like to see how registers are being used, parallel series, how to calculate and whatnot. And I am very weak in theoretical information. I try to tend to learn a lot of things by doing experiment, or you can say by trying things out. For example, if you tell me, okay, uh, to write a program, okay, not a program, like for example, okay, use a register. Okay, use a register as a pull up or pull down. So like there's always need of a pull up and pull down if for a particular reason, or not particular reason, depends on situation to situation, on why do you want pull up resistor or pull down resistor, high impedance and whatnot. So thing is, I can't remember the theory. Okay, but I can I when I try things out on a breadboard, when I see what is the outcome of those particular thing which I do, I those things is in my mind now, because I have first hand experienced it rather than just remembering a theory. For me, remembering theory is very difficult. That's why I try to experiment. Sometimes I burn some things like ICs or whatnot, but yeah, even if I am, sounds like I'm burning things, okay, it's not good, but it is good for me because I'll know what made that burn. Okay, like sometimes theories, you shouldn't just bound yourself to theory, and it is also true that you shouldn't just bound yourself to practical, because you should know little bit of theory. Okay, but for me, I try to keep up with theory. I Whenever I'm trying to do something new, okay, I'm making something new, I try to go online, I try to read, I try to understand, then I try to implement into those concepts practically. So that's where I try to learn. Okay, but most of the learning, even if it is theory, I try to implement it practically, then I understand it. Just I can't understand anything just by theory itself. I'll Yeah, I'll make you understand later on. So yeah, I learned a lot of things, and back in the days, Arduino's, ESP8266, then more of the microcontrollers were in a very hyped up form, or you can say that was a go-to thing. Okay, that was a go-to thing for each and every person who is trying to learn new thing, who's trying to build something, prototyping or something, right? So people try to get Arduino boards, Arduino development boards, and try to implement it into their project. Okay. And they kind of tend to make something like on a breadboard. Okay. This is an Arduino and this is a different microcontroller development board. I'll talk about it later on. So they try to use something like this and do some experiments and write a firmware. Okay, for why I am saying exactly a firmware, because program is just a program where if you are making a program for a particular use case, it becomes like, for me, I consider it as a firmware. Okay, for example, this one, it is this basic, I'm trying to communicate on a high level or low level, you can say. Three Arduino works on 5 volts and this is a controller works on 3 volts. Their data signal is on a different level, like 5 volts, 3.3 volts. Then I need to use a MOSFET to, logic level shifter kind of thing. Yeah. So I wrote a firmware which is essentially a small program to communicate with each other and to get a response and whatnot, right? So keeping that aside, those things I learned. Okay, but during this whole series, I won't be doing that kind of thing. I will be working as I don't know anything. Why I'm gonna do it like this is just because there are a lot of my friends who's gonna be watching this stream, and there are a lot of my new subscribers or new people who are gonna join this series, and few of them will be very intrigued to see how they, like, if there are a lot of people I know and I don't know who wants to change their like career or something. Even I did. I went from bachelor's in IT, like from an IT to robotics and then electronics. Okay, I kind of changed it twice or thrice. So I know it is very difficult to change your career in general, but when if someone is doing, you can do it as well, right? But how you wanna go it moving forward? Okay, so this learning electronics and this series is actually me trying to show you guys that even if you are like don't have a knowledge in electronics or any other field, you can still use online resources to learn and to actually make something good. Okay, so let's, yeah, so I did my masters in robotics. Yeah, so that was just my stepping stone to get out of the IT background, because just learning things like a hobby, like being in a hobby kind of environment, is not gonna make my career bright, or you can say I wouldn't be learning a lot of things. So, but I learned a lot of things by myself, like why do we need a pull-up resistor? Why don't we need a pull-down, and like how to program a microcontroller? What are LDOs? Why do we need voltage regulation? What is high switching frequency and what are not? Okay, I learned a lot of things. Okay, no one, there was not a single person who taught me like in person or like giving me a like lecture or something. I just learned all those things from internet and by trying things out directly. For example, I tried to make a microcontroller board using 80 mega 328p for my own project rather than using directly an Arduino. Then I just randomly picked a regulator, okay, to step down 12 volts to 5 volts, but I wasn't careful enough. I accidentally picked a 12 volt to 9 volt, and I directly hooked it to my microcontroller, and my microcontroller burned. That time I realized that, yeah, it's, even if the ICs are looking like the same, there are difference, because you have to go through the data sheet, you have to check the part number, you have to also check the internal resistance, what is the voltage drop they are gonna have, what are the heat dissipation is like the power draw and whatnot. You have to consider a lot of things. Those things then I realized after burning a lot of things and making things good. Okay, so during this whole time we are also gonna learn those things but we are gonna learn using AI tools, like for example ChatGPT. I'm gonna particularly using gonna use ChatGPT for most of my things. Okay, so and we will also try to look for some other alternatives if we can find to particular use cases, because nowadays if you just go on internet and try to find a AI tool to generate an image, okay, you will get tens, 15s, like how many you want, you will get different tools based on ChatGPT and using their APIs and whatnot. Okay, but when it comes to like not just about image generation, video generation, audio generation, now the people are cloning or like voices. I was so surprised just by trying one of those tool for myself. Okay, I was very mind blown. And if you are following me on Instagram, you will be you might have seen I have given the teaser of this particular uh series. Okay, I give an advertisement kind of thing using an AI based, AI generated image of myself. It doesn't look exactly like me, but somewhat like me. And I use my own voice. I didn't train my audio because free. When you are trying something free, you have very limited amount of things you can do in that. And my uh, video, the thing I posted on Instagram and on LinkedIn, I guess. Okay, it was 41, yeah, 41 or 42 seconds long. Okay, my audio clip was 41 or 42 seconds long, and it was not able to clone it. Like I had to write a script for it. Okay, but the character amount, okay, the words which I was using were long, and it wasn't fitting into the free quote. So I left it, and I used my recording, and I used my image into a different AI tool to process the video. It basically made it look like I am actually uh using a camera with just a filter on, something like that. So okay, so there are a lot of AI tools available in the market now. As days goes by, you will find more and more and more and more. There is one AI tool particularly for designing circuits, but it is only available for organization or a company. I did took an demo. Okay, I requested a demo as an individual because I was very curious about it. I wanted to try it on, but apparently they are offering it for individuals, but I can't afford that individual license at the very moment. We will see it in future. Like if I get support from all of you guys, then definitely we can make it happen. And I'll definitely put the I'll definitely show you the website later on which AI tool I am talking about. So if you wanna try it out, you can get a free demo. Demo means the person who is like someone from that company is gonna give you a demo over the Zoom call or Google Meets. And if you want to try it yourself, you have to enroll for a free trial period by promising them like that you are gonna be a subscriber. You can free like cancel it for free, but still, okay, the amount you are gonna promise is kind of little big. So if you are working in a company or in an organization, it is fine, I guess. Okay, moving forward, let's start with the actual thing we came here for, right? So let me connect my graphic tablet so I can it will help me to illustrate or to write things down and show you guys like a demonstration of why we are doing things. And there are a lot of people who don't know what are microcontrollers and why, like small concepts. So you can say like just to differentiate between CPU and central processing unit, CPU, which is used in our computer systems, and MCU, microcontroller unit, okay, which is being used in small different peripheral devices. Or like, okay, we will talk about it like what are the basic difference and why. Okay, before that, let me change my scene. So what it was, F3. Okay, you are able to see my screen Right now I am not on a, like for example, I don't have a multiple display at the moment. I only have one display. So that's why I'm planning to get one more. Once I get another additional display, I'll shift this. For now, welcome our Goku Sama. Okay, and I'm gonna just a second. One of my friends said the link I posted on Instagram is having some issues. Okay, let's continue with our thingy. So what are we gonna do is we will open a software which will help me to show you guys or to direct. Okay, this is Autodesk Sketchbook. This one is a free version, not a paid one. Just to give you a disclosure that I am not gonna be using any of the paid softwares because even I can't afford to pay the software, so I'm just using a knockoff version of them. Yeah, just to give a disclaimer, that's why while streaming and while guiding you guys, I'm gonna just use free softwares. All right, let's say I try to write things like this. So let me adjust whatever my graphic tablet, and let me also turn on to see if there is any chat people. Okay, let me keep my phone like this. All right, so uh microcontroller development board. For example, we have a microcontroller development board like this one, like all in all the basic Arduino. Okay, let's go to Arduino official site and we go to their hardware section. All right, and we have bunch of different families of microcontroller board development boards. Okay, you can choose any one of these for your like depending on your requirement for your projects. But you can use this okay, you can use this development boards when you are trying to do prototyping, when you are working to test something out and whatnot. But when you are making a product, you should not, like, I would recommend not to use a development board into your product because it gives you a lot of flaws. Because if suppose if some other person open like dismantle or tear down your product and they find out that you are using a microcontroller development board into your product, like basically you are integrated, but still they would be easily able to replicate your product, and as well as they will be able to find or do a lot of stuff. Let's not get into detail, but yeah, like all in all, it is not a good thing to, like, when you are releasing or publishing or selling a new product. Okay, it is not advised that you integrate or implement a development board. Okay, so as you can see, there are a lot of different variants of development boards. Back in my days, Arduino Uno R3, Arduino Mega 2560 or F3, and Arduino Leonardo. Sorry, my pronunciation is very bad. Okay, these three, and then Arduino Nano. Okay, there are a lot of Arduino Nanos, but the ones what I'm talking about is this one. Okay, these four microcontroller development boards were very famous 4 5 years ago, and even now they are kind of a famous, but because there are a lot of competitors coming in from the background, or you can see new companies are coming with their own microcontroller development board products. For example, STM32. Okay, which is basically ARM based microcontroller. It is a 32-bit version ones. But Arduino, most of the Arduino based microcontrollers are 8-bit. Only there are only one or two development board from Arduino which is for 32-bit or ARM based or AVR based. Okay. Sorry, all the development microcontrollers are AVR based in terms of Arduino because they are using Atmel microcontrollers in them. Okay, so this is how your microcontroller development boards looks like. For example, we go in this one and just escape. So in a microcontroller development board, okay, you have a microcontroller. So we will draw a microcontroller. We have a microcontroller. Okay, my drawing is bad. Okay, then we have a you can say this one is a communication interface between your computer and your microcontroller. So we say we have a communication interface. We will just note it as a CI. Okay, then what we have here a power circuit, which is basically we give a 12 volt over here. As I've mentioned it before, microcontroller tend to work on low voltages like 5 volt or 3.3 volts. So this particular microcontroller needs 5 volt. So we have a voltage regulation circuit over here. Okay, then as you can see there are a lot of pin headers over here which is actually connected to our microcontroller. Okay, any of these pins can be used as an input or output. So I am just gonna draw an arrow like this which shows a bidirectional communication, as I said, input and output. So it can be an input or an output, okay, not both at the same time. Okay, then we have a we supply 5 volt to our microcontroller, and we also have few pin headers of 5 volts to this. Okay, I'll just remove this one. You get the idea of what I'm trying to say. So now communication interface is also connected to our microcontroller in two different connections. One is TX, one is RX. Okay, in RX, microcontroller sends data from its memory or its pin to communication interface controller. Then it communicates with our USB port to our computer. Okay, my bad. I tried to make a box. Okay, sorry. So this is how basically uh, microcontroller development board used to be back in the days. Okay, 4 or 5 years ago it was something like this. There wasn't a lot of things apart from how, like, you can say IO, input or output ports, which you can use it for. My bad, sorry. How shit, me let me okay, my bad. I haven't used the software too much, so sometimes I tend to forget how to move things around. Okay, so yeah, IO ports, we can attach an LED, we can attach some other sensors, temperature sensors or whatnot to measure temperature of whatever you want, uh, like that. Okay, so back in the days you can see this was how it was, but as you can see now, sorry, my bad, let's just go back. Now if you see, for example, this ones. Okay, let's go the one I'm very familiar with. Okay, IoT based. Okay, in this one there's a microcontroller right here. This is a microcontroller. Okay, this, I believe this one is a interface which communicates between, no, it's not an, okay, this is a voltage regulator, if I believe. I have to check, like, to get a confirm answer, we need to check our schematic or something. We can go in documentation, we can see a schematic PDF. I'll just download and open it for you guys. So as we can see, uh, not now. Okay. Okay, let's make it a default. Okay, now as we can see here, it is, we have a 3.3 volts, 3.3 volts, 3.3 volts plus, what is D21G18? MP36. We need to find the part number and we need to get to know what that particular device does. So let me close this one. And what was the part number? D21 and G18. Okay, it is a low power microcontroller using 32-bit ARM Cortex processor and ranging from 32-bit to it. So if I am not wrong, it is a part of our main microcontroller D21G18. Okay, this is a part of a microcontroller which is only supposed to have connection for the power circuit. So that being a part, MPM3610 should be our voltage regulator. If you give, okay, my bad, if you can see, there is an voltage Vn over here and we are getting as an output as 3 plus 3 V3. We are not gonna get too much into detail, but just to get a basic idea, we have our input and there is a regulated output of 3.3 volts. It is just stepping it down. And then we have, I guess this is our, uh, the one we are trying to look, MP or something. Okay, we can have a look later on, I guess. But in general, we have an onboard GPS or a Bluetooth system, U-blocks. Okay, so we have an onboard GPS or a Bluetooth or Wi-Fi system. I'm not sure. I haven't used this product. It is mostly like focused towards IoT. So I believe it should be GPS and a Wi-Fi integrated system with a voltage regulation, a microcontroller, and sensor, as well as I believe this should be an EPROM, okay, a flash storage or something on board which will help them to store any kind of data on it. Let's just keep this aside for now. So basically, in general, when we say, when you are trying to develop a microcontroller development board, what do we need is, just a second, what do we need is a microcontroller. Okay, we need a voltage regulator. Okay, so we just make a basic connection. Okay, or let's why am I saying we can ask chat gpt. Try ChatGPT. Sorry, I need to log in, guys. Let me just log in. Okay. Ha. Why is it like this? Give me a second. Let me get it looks like this is a very phone number. Huh. Okay, let me skip this and I will open the other one. Okie dokie. Guys, let's get going. I believe this is working. Okay. Is it not bright enough? Okay. So this is something I have plugged in. You can see I have been using ChatGPT for quite some time, and yeah, I have some extensions from a IPRAM, AIPRM. Okay, if you wanna sit like that way, let's just close the other tabs and let's say uh consider you are a professional electronics engineer. Explain me the important to have in a microcontroller development board. Let's see. Okay, ChatGPT has given us a well prepared answer, and I am kind of very proud of myself that I have actually written something useful, and it has not given me a wrong answer, like a proper answer. Okay, so according to it, as a professional electronics engineer, I would have blah 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 blah. It says, but a microcontroller development board is a hardware platform used to prototyping and developing applications using microcontroller. It typically includes the following key component. What are these key component? Hello, Sidhu. Hi. Now, first component, the heart, brain, whatever you want to say, like the brain of the development board is our microcontroller. Okay, let's my bad, let's open this guy and we'll select all, delete, and this we will use our pen. We have a MCU, microcontroller unit. Okay, we have a microcontroller unit. Next, it says we need to have a power supply. Okay, a stable and reliable power supply is essential for proper functioning of the microcontroller and other components. We just not need a power supply. Just okay, okay. You as per the question I have gotten from Siddhant, can you explain why we use a microcontroller first? So, in nowadays, in each and every devices, okay, to work it very smartly, or like to make it work as we want, okay, like we can't just use any discrete components to make a logic circuit and it will do as uh, taking the input from the conditions, process it and do it anything. We need a device or a chipset which will take those information which we provide from like IO pins or something. It takes the temperature in, it processes it, and then it gives an output in terms of controlling a heater. Okay, for example, if you are if you are having a greaser in your apartment, okay, which makes your water heat, okay, you get a hot water in your tap, it needs, okay, a device, or it needs a brain inside it, or else it will just keep heating the water so much that you will burn your skin, right? To make that temperature not go beyond a certain amount, you need a brain into your heating device which will know what is the actual temperature, okay, of the water, which the device will get from its sensor, okay, and then it will process according to the algorithm we have written or we have uploaded onto that brain, okay. So that brain will only work around that particular algorithm. It will continuously check the temperature and it will try to maintain the heat, or you can say the output of your temperature, right? It is a loop or something, but all in all, you need a microcontroller to control something, okay, small devices, something. For example, when we are using a computer, okay, I feel like I'm taking this explanation in a very big loop, but in basic example, you need a microcontroller to control certain device which is very complicated to handle just by yourself, okay. For example, heating water, okay, it is like quite complicated when you manually do it, unless until you are heating it on a gas stove or something, you can just control the flame. But when it comes to doing it electrically or electronically, you won't be standing around the main switch to check the water temperature is heating and you will turn on and off. So you use a microcontroller, write a firmware that check the temperature, and you do that manual switching into the microcontroller. It will then regulate the heat, okay. So microcontrollers are like integrated in multiple devices what we use daily on a daily basis. For example, TV remote, okay, your mouse, okay, the mouse which we are using has a microcontroller in it. It has a different set of instruction. Yes, Siddhant is very much better in explaining the theoretical information than I am. So, so he said like, so microcontroller can be programmed to automate a certain task which, okay, sorry, shit, which require a lot of human intervention, right? Yeah. So make it in simpler terms. That's what the right answer is. It can be used to automate a lot of things to you know the people like us. The thing which is complicated for us can be easily done by using a microcontroller. In simple language, I guess I exaggerated a lot of things which is not necessary, but still I believe a lot of people knows and a lot of people doesn't know. That's why I am using ChatGPT to understand. Okay, thanks Siddhant for supporting and joining the live stream. So moving forward, yeah, microcontroller has a lot of IO capabilities and support programming. If a microcontroller don't have the capability of a programming, so it can't we can't say it is a microcontroller, because If you can't program it, you won't be able to, control things. All right, just a second. Moving forward, as we were saying, power supply, we need a power supply to, thank you, thank you, thank you. Thank you, Siddhant. Ha, yeah. So when we need a power supply, okay, like microcontroller is not gonna power it by itself. Like it doesn't have any kind of resource or like a source of energy, so we need to provide it. So in a development board, it is very mandatory to provide power. We connect a battery or we connect a USB charger or something from which it will take that power and use it for its like for whatever it wants to do electronically, to switch a circuit to glow an LED to read some information or from the sensors or whatnot. Okay, so we need power supply for microcontroller itself, as well as for any peripheral connections we are gonna have, or IO ports or anything. The third part, we make a what was it? Power supply. Power supply. We are not gonna use power supply unit. We are just saying power supply. So PS. That's it. Now clock crystals or oscillators. According to our AI tool, it says microcontrollers relies on accurate timing for their operation. Okay. A clock crystal or an oscillator circuit provides the required clock signal to synchronize the operation of the microcontroller. It helps maintaining precise timing for tasks like data sampling, communication, and signal integration. Just to give you an example, we as a human being work, eat, sleep, repeat things on our daily life based on timing. Okay. For example, you are working, you have to clock in to your office at suppose 9 a.m. And to make sure that you are reaching office and starting your day, you have to leave your home an hour before or 2 hours before. Okay. So you are always using your watch to see what is the time, and based on that timing you are able to perform your task appropriately or fluently or smoothly. Dude, my power supply converter. Yeah, yes, for sure, a PSC. Let's say power supply converter or step down. We can say a step down converter as well. Whatever, it's fine. Uh, so as I was saying, we need in real life, as a person to person, we need a time. We are relying ourselves, each and every task is based on time. You get a deadline at work that today at 5 p.m. you have to submit your presentation, and it's already 1 p.m. Depending on the time, you are gonna put more efforts because you wanna finish your task before that time so you can submit and you don't get scolded from your boss. So that's the general rule. Why do we need time in real life? Similarly, we need timing for our microcontroller as well. So our microcontroller knows what is happening, okay, like communication, okay, signal generation, and sampling. For example, I want to, as I given you an example of water heating, right? So if there is no clock cycle, it won't know when it needs to check in how what kind of interval. Like suppose every after 15 seconds you check the temperature, and if the temperatures are high, you cut off the heating. If the temperature is low, you turn on the heating, right? That's the basic rule of thumb of how heating should work. So if there is no timing, okay, given to a microcontroller, okay, it won't know when that 15 seconds has already happened, it's past, or is it approaching. So if we give a precise clock input using a crystal clock or a oscillator, it knows that okay, 15 seconds is approaching. I need, once 15 seconds is done, it will take the readings from the temperature sensor, and then it will process the information, and it will see if it needs to cut off the heating or not, right? So giving like timing, like adding clock crystals and oscillators to your microcontroller will help you to do a lot of things. Nowadays, lot of microcontrollers are having a built-in crystal oscillator which gives timing. We don't need to add an external crystal oscillator. So many times you in back in the days, so like couple of years ago, it wasn't possible. A lot of microcontrollers, like even if you see our Arduino, okay, Uno, this guy has a crystal oscillator. As you can see, this is a crystal oscillator which has been connected to our microcontroller to give a precise timing. How does this crystal oscillator works, and like a very particular, very detailed information we will look in future when we actually require it. Okay, for now, just a rule of thumb is we need crystal oscillators into our microcontroller, so we are having a very precise timing of what is gonna happen. Like for example, you're giving a delay or whatnot in your algorithm, we need that for it. Okay, now input and output pins. We have microcontroller. Okay, it all microcontroller has an IO pins which is used to interact with external world, for example temperature sensor. Okay, and this pin allows you to connect sensors, actuators, display and other external devices to develop board. As I given, you have the water heating example already, that you need uh, microcontroller is taking the sensor input, okay, reading the value of the sensor, temperature sensor. It is reading through the IO pins. Okay, one of the IO pin is connected to the output of the temperature sensor where everything happening, and it is reading the information and it is able to process it. And the other IO pin is connected to a switch, okay, which is making the heating element into that heater on and off. So the other pin which is connected to this switch is an output from the microcontroller. For example, we have a microcontroller over here, right? This is a switch. I'm very bad at drawing. Wait, let me. We have a switch, okay. This guy connects here, and we have a heating element. We just say like this, and we have a temperature sensor. Temperature sensor gives the input. According to the algorithm, it process, and then it will decide if it wants to make the switch on to make the water more hot, or it wants to turn the switch off so the water doesn't get very hot. Okay, you get the basic understanding? I hope so. So let me just remove these as we don't need it in this part. So that's why we need IO pins, so the microcontroller can have an interaction with the external world or other devices. Now, the fifth part, we have like let's just, it already have IO ports, so we just need to make a pin header, PH or PING ADDER. Am I right? Am I wrong? Let's just keep PH, pin header. Sometimes I get confused of my spelling, so don't mind me. Okay. Communication interface. We need a communication interface in a way that we will be able to program the microcontroller. If you don't have a communication interface, we won't be able to interact with the microcontroller to upload the program. So the microcontroller read that program and do its task. Okay. So normally in microcontroller we see different types of communication interface, but the most common one is UART communication and a USB connect communication, because we use USB communication and UART communication. Uh, the term is USB to serial communication. Okay, UART is considered as a serial peripheral device. Okay, just like SPI, as you can see here, we have SPI, serial peripheral interface. As you can see, UART is also considered as a serial interface. I'm not saying serial peripheral interface, just serial interface. Okay, now this communication interface takes the communication, or you can say bridge the communication between our computer. So we have a communication interface, we have a personal computer. It bridges the it bridges the communication. Okay, development board often include built-in communication infrastructure to enable connectivity to other devices. But in our particular case, when we want our microcontroller to talk to our computer so we can upload program as we like, we need to have a separate external communication interface, okay, which allows to convert the data from the USB protocol to UART protocol. Okay, we will talk about the protocols on a later state, but as you can see, all this interface works on a different protocol. These protocols are SPI, I2C, inter-integrated circuit. These are a full form name of all the short names which which we are gonna use many times: SPI, I2C, and UART. I have personally worked on mostly UART and I2C. You will see SPI communication mostly on very where you need speed. For example, memory communication or something like that. Okay, when you want to interface a onboard memory or something like that, we use SPI. So this SPI I2C UART interface is already present in our microcontroller. Okay, but the communication interface which converts our USB communication to a sorry, my bad, to a UART communication, we have to add it externally. In many of the microcontrollers nowadays features this chipset in it, like it is integrated, so you don't need to actually implement this. So it communicates between the PCs and your microcontroller, but in many of the cases we need a external communication interface which converts the USB communication to our liking. It may be UART, it may be I2C, or it may be SPI. It depends on what type of protocol or communication interface we want to use. Okay. Now we have a programming or debugging interface in a microcontroller development board. This will help us to debug if there is any issue or any kind of thing. Okay. Like in Arduino boards, not all the Arduino boards have any debug interface support. Okay. And nowadays the chipsets like STM32, ESP32 has an separate debugging interface which you can use to debug and to read the memory, what is happening in the background and whatnot. So that interface is basically a pin header which is connected to a specific pin on the microcontroller. Okay. Which has SWD, which is for STM32 or something, other microcontrollers. Okay. So this debugging interface is already built in to the microcontroller. Few of them we need to add it externally, but we are not gonna be doing something that crazy complicated stuff at the moment. We will learn about those things as we move gradually. We are also not gonna implement memory onto our upcoming project, but to just give you a basic idea, microcontroller requires memory to store program code and data. Okay. This guy is giving a little bit of wrong information. Okay. Microcontroller. Okay. Just to give you the thingy that how do I move my page? Oh, moving like this. Okay. First let me, okay, I'm able to move now. So microcontrollers, dude, why am I doing this? Okay. So just to give you a simple thing, microcontrollers have a CPU, a memory, we have a RAM, and we have a storage memory, or you can say flash memory. Okay. Combining all these three guys, we get a, yeah, there are a lot of more things like IO registers and whatnot, but the things which a normal CPU and a MCU is differentiated based on this thing. A CPU which we use in our computer, okay, we have to add an external hard drive where we upload our programs, we upload our operating systems. Okay. We have to add an external RAM. We can expand that RAM for sure. Right. And we can uh just a second. I guess I need to open I'm not Siddhant, sorry, but I guess apparently my phone is not working that well to read chats. There are some pop-ups coming on at the bottom. Let me open my YouTube on my other phone to see. So yeah, so you were saying, would microcontroller be a called as an SOC? Yeah, Microcontroller can be called an SoC because it is an entire system on chip. Okay, yeah, system on chip. Yeah, I know. It's the thing is, my iPhone is giving me a lot of emojis. Okay, when your comment comes up, the comment is hidden because of those emojis, and for it is difficult to read those comments. So that's why I have to use my other phone to check what you have written now. Okay, so as I said, our computer has a different different things into our like computer, like for example CPU, RAM, memory, motherboard. Okay, so motherboard is the thing where we put all those different components like CPU, RAM, and storage, and then we upload our operating system, and then it is able to communicate with each and everything. Okay, we have a BIOS in the background which is responsible to control the voltages to communicate between RAM, CPU, flash storage, and whatnot is on the board and whatnot. So in microcontroller, it is a all-in-one package kind of thing. Okay, in microcontroller, we have onboard memory. Okay, we have a flash memory. We have two type of memory: flash memory and a RAM memory. Okay, RAM usually uses as we use in our computer to. Thank you. RAM is basically, we use it to store some information which is not gonna be used for a very long time. We just need to use it for an instance or to keep it for a temporary use. We use RAM. Then we have a flash memory where we store all our program data. Okay, when the microcontroller boots up for the next time, it checks the information into the flash memory, it loads onto the RAM, and then CPU processes and work as it should as per the algorithm we defined. So that's why RAM and our my bad. I need to learn the why am okay is not move. Okay, let me use this guy. Okay, V is our shortcut key. Okay, so when our chat GPT is saying microcontroller requires memory to store program code and data, the development board should have sufficient memory for program storage and RAM for data manipulation depending on requirements of your application. This thing has to be considered when we are choosing our microcontroller, not to add it additionally. We use flash memory, external flash memory to store large files. Okay, for example, you want to log something, you log those things on your external flash memory, which is on your development board or on your any kind of product you are designing. Okay, that's why we need an external flash memory which is based on SPI. We can't technically increase the built-in RAM and built-in flash storage. There are few microcontrollers which has the capability of redirecting a few of their you can add more addresses. Okay, so that's a very complicated topic to talk about, which I don't want to talk right now because even like thank you, thanks for joining, Siddhant. Thank you. So yeah, so it's a little bit complicated topic to talk about when it comes to external storage. As external storage, we have to consider a lot of things. We also need to think about if the microcontroller we are going to use is able to support external storage and what is the maximum limit it can support and whatnot. Okay, now the project we are going to build for this kind of series. We are not gonna be using external storage for now. If we want to use external storage, we can think about it later on. Now we have a reset circuit uh, to give a, okay, let's see what it's saying. A reset circuit ensures the microcontroller starts in a known state upon power up or when a reset button is pressed. It typically includes a reset switch or a pull up or pull down register and a reset controller to manage the reset sequence. Entirely true. We need to add an external reset switch. For example, if we are executing a complex algorithm on our microcontroller and it gets into a loop where it is not able to come out of the loop, there's a situation if it is not able to come out of the loop and you don't know what you want to do, so there should be a reset button on your development board or a product. When you press that reset button, it restarts the process or the algorithm from the first line of code you have written. Okay, so that's why we need a reset circuit. Then we have LEDs and user buttons. It is entirely upon user requirement if you want to include LEDs or buttons for feedback and whatnot. Okay, and voltage regulators and decoupling capacitors. Okay, this is kind of very technical. This will we will cover this thing when we actually start designing a circuit board. As for now, we don't need to understand why do we need a decoupling capacitors, but voltage regulators is already is already included into power supply part, because when we give 12 volt into our when we give sorry okay, I need to use black. When we give 12 volts, okay, to our PSU or regulation circuit, okay, it steps down to 5 volt or 3.3 volt. This is how the power supply circuit or power supply step down converter works. Okay, you can also boost up the voltage, but we in our case we don't require boosting the voltage from 12 volts to 15, 16, 17 volts. We actually need to step down so our microcontroller doesn't fry. Okay, this much, I hope this much is understood, and now we can start thinking about the project. Not thinking, actually I have a basic idea what I want to do, so I will talk about it. We will brainstorm what are the requirements, what we will need. We will think about how we can implement like, I don't want this particular board just to do a single task. I want it to do multiple tasks, so we will do some brainstorming. We'll get some ideas and how can we use this particular thing in multiple different ways. I just don't want to make it for one single purpose. As you know, microcontroller development boards are used for multiple things. It is not just meant for one particular use case. Just like, for example, sensing temperature, you can use a microcontroller development board to you can use microcontroller development board to do multiple things. Okay, to control a motor, to control um I hope, just a second, I hope, yeah. To control the LED light or the brightness of the light, to take audio, video, amplify it, like to do a lot of things. Okay, so but I have a lot of particular use cases I want that board to fulfill. Okay, why is that? I'll also explain it in couple of minutes after taking a very short break. Okay, So we will be right back in 5 minutes, guys. Wait a minute. I am not able to see my chats. Well, isn't it weird? Browser setting. Okay. I have to look onto this thing later on, I guess. Because. Okay, fine. I'll have a look later on. Why the chat thing is not on the right side. Okay. So, I was saying. Recently I have been involved in working with a lot of batteries. Okay. It was the same, I guess, before as well, but it was more over. I was concentrated towards drone because I was flying drones a lot, and I wanted to, monitor the battery, the health of the battery, and whatnot. But now I am working on a lot of like complicated stuff for with low power consumption and whatnot in my office. But that doesn't stops me to learn a lot of things personally. That's why I thought of because in this case I have few components already in my hand which I want to use, and we will also be able to see what are the alternative we can use in that case. But let's write down what I want. Okay, the you can say client requirements, what the client wants. I'm the client, and we will write it down. But we will also see how can we use ChatGPT to make those information in a well structured manner. So we will write down things in a notepad first, and then we will ask ChatGPT to make convert this thing in a professional documentation, so we can make proper documentation as we move further, that okay, this is the requirements were this, then over the time the requirements changed, and we according to that we choose these components and whatnot. And after the whole project is done, I will be creating a website. I will also be creating a Patreon page where all this information will be available to the Patreons. And if you are just subscribed on my YouTube channel, and if you are just looking at here, you are able to see what I'm doing. You can follow those things. But if you directly want to get the access, then you have to be my Patreon. And once you get into like my Patreon thingy, or even on my website, you will be able to get all the files directly. All right, so let's open a notepad and let's get started. Okay, I have a notepad here opened up. I hope you are guys are able to see. Let me just confirm if my mic is also on. Okay, so let's just say requirements. Okay, wait, what? Let's say what at private setting, apply your account private setting. Okay, we will say 16, 26. We have requirements. Okay, requirements. First requirement is uh, I have lot of microcontrollers in my apartment. Like I have a lot of microcontrollers in hand. So I want to utilize those microcontrollers. Okay. So I'll just write down what are the options I have. It is STM32 F030, then STM32 G030, I believe. I think these are the two microcontrollers I have a lot in my stock. It's like more F030 than this. We will also see alternatives. Okay. First requirement would be this. I don't want to create this thing. Second requirement, this board should has a built-in charging circuit. It should it should provide autonomous charging as well as manual charging. Like it should be controlled with the algorithm, or if I don't want to control it, it should be directly thing. So we will explain it to you later. Built-in, I am saying battery charging like 3.7 volt lithium ion or lithium polymer batteries. Okay. Third requirement is I want to measure the voltage and the current. Here we will measure the CHARG, charge and discharge. I would say monitor charge and discharge current of the battery, then monitor the voltage of the battery. Then I need uh, communication interface for USB. Then I want uh, some extra IO pins for each task extra, which can be used for any task in future. 7, we'll say just PREFER as in stock, or is this can find some alternatives. Then I need, what else do I need? I need end display. OLED on buoyed OLED, onboard OLED display. These are my basic requirements. Okay, let's ask ChatGPT. Okay, so what I'll say is you you are a, what is the person called, like documentation specialist. Please write, please use this requirement and it in a professional manner so it can be used for J project management. Oh, okay. We can say consider your documentation, documentation, documentation specialist. Okay. I want you to make use of the. I want you to make a PROESSIONL professional. Make a. I want you to document the ROJCT in a PRO professional manner. This DOCUMENT is to a be used to document the project development. So here is the requirements for Women Studios document. So we just copy this and paste this here, and we copy this from this to this point, and we go to our chat GPT guy, and we create a new page this and just enter and see. See, it is so easy to just give couple of lines of information and write down a entire document for just requirement or like anything. So what we are gonna do is, even if it is generated by AI, I don't care if I want to make it like you, if it is written by human. Okay, that's the best part if you are working for yourself. If you are not working, if you are working for a company, then definitely you can use something similar to the AI it or whatever. Let's just see what it is written. Project documentation for battery monitoring and communication system. Introduction. The purpose of this document is to provide a comprehensive overview of the document and functionality of the battery monitoring and communication system. This system is designed to monitor the charge and discharge current as well as the voltage of a 3.7-volt lithium ion or polymer battery. Additionally, it's a it in, incorporates a communication interface for USB connectivity, external I/O pins for further expansion, and a onboard OLED display for user interface. Hardware selection. Okay, we will just ask him. This would be change the project to thing related to MCU incorporating. Am I wrong? P incorporating features like battery and so let's see what it says. MC development board with battery monitoring communication system feature. Okay, the purpose of the document is to provide comprehensive overview to development and functionality of the development board. With the battery monitoring and communication interface, the development board is designed to incorporate various features including battery monitoring and communication system to provide a versatile platform for micro MCU-based projects. Hardware selection. The key component of this development board is a microcontroller unit. Two options have been considered for this MCU, and this the preferred choice is due to its availability in stock. However, they can be considered as an alternative if the preferred option is not available. Both MCU offers ample features and capabilities to meet the requirements of the development board. Good. Uh, Battery monitoring. The MCU development board includes functionality to monitor the charge and discharge current of a connected battery. This features enables real-time monitoring of the battery's performance, allowing user to access its health and usage pattern accurately. Good. Battery voltage monitoring. In addition to current monitoring, the development board incorporates the ability to monitor the voltage to the battery. This feature provides essential information about the battery states of charge, helping prevent overcharging or deep discharging, which can negatively impact the battery life. Good. Communication system. The MCU development board features a communication system that allows for communication interface, enabling user. Oh, sorry. For convenient connectivity and data transfer. The system incorporates a USB communication interface, enabling user to connect the board to a computer or other USB-enabled devices. This facilitates seamless data exchange, configuration, and firmware update. Extra I/O pins. Its development board also include additional I/O pins, providing flexibility for further expansion and customization. These pins can be used for connecting external sensors, actuators, or modules, allowing user to incorporate additional functionalities as required by their specific project needs. Right. Onboard OLED display to enhance user interaction and provide a user-friendly interface. The MCU development board includes an onboard OLED display. This display can present relative information such as battery parameters, current measurement, voltage reading, and other system status information. It can offer a clear and convincing visualization of data, simplifying user interaction with development board. Conclusion. So basically, uh, it actually have kind of a written the introduction of the development board we are trying to make. So this is very good. Okay, as if I want to, when I'm designing the website, okay, I will be using this information instead of using this for documenting, like a project documentation. I want to make a uh, how to document a project. Let's ask how to do you do the project from to end. Okay, we're getting a lot of things. I'll say using this structure, modify the data which was, let's see. Let's go. We are able to generate a proper thing which we want. So we are gonna fill more information later on. Okay, it has modified the things, each and everything, and we need to fill these things later on with images and whatnot. But yes. Okay, project documentation, introduction, project overview, the MCU development board with feature is upper project tab to create. Okay, okay. Ask as many question you want. I want an output. Uh, I want a detailed introduction for this project. You can ask me as many question you want, so you can give me a well and structured introduction. Let's see. Okay, it's asking me about these questions. Project background: to provide a detailed introduction of the MCU development board with battery monitoring and system feature. It would be helpful to gather some additional information. Please provide the information detail. What is the main purpose or goal of this project? Are there any specific industry or application area that the project targets. Okay, is there any particular program problem or need that this project aim to address? Are there any existing solution or product in the market that are similar to project? By providing answers to this question, I will be able to craft a well detailed and structured introduction for this project. Let's write the answers for this guy. uh let's go to a new page. Okay, what is, let's copy this thing, write it down here, sorry, my bad. uh Paste. Okay, I'll just drop down a little bit, like around 22, if that's okay. New page, guys. What is the main purpose of this project? This MCU development board as per the uh this MCU model should be work as a okay, so main purpose would be like it should work as a smart battery charging for lithium ion or polymer batteries. The sec in the us and we can measure this the LDR alternative would be the can use development, yeah, to just like any other any but the but the functionality of onboard and onboard battery charging and monitoring using a API which I'll or the user can make its own. Okay, so I guess this is pretty much it for the thingy. First question: are there any specific industry or application that this project target? Uh, this project, the low uh, low power applications and on board and low power applications and current consumption. This project targets a low power low power device. This project targets low power where it is to monitor and needs the flexibility of IO pins and is that right? Flexibility to work with. Let's just say this much. Is there any particular problem or to aim to address? Many of the MCU DVLO DMENT beyond not on board and this. Error but indifferent modification and let's copy this guy from this point to this point and paste here. Let's see. So I guess it has written the introduction. Let's just read it once. Project background. The MCU development board with battery monitoring and communication interface features a multi-purpose development board designed to cater to the needs of low power application that requires battery monitoring and flexibility in functionality. This project addresses the lack of integrated onboard charging and monitoring systems in many existing MCU development boards. By incorporating this feature, it aims to provide a comprehensive solution for developers and users seeking an versatile and convenient platform. Nice. Just need some changes. Main purpose and goal. The primary purpose of this project is to create an MCU development board that serves as a smart battery charger for lithium batteries. The onboard sensors and OLED display enable precise measurement and display of relevant battery data, allowing user to monitor the charging process and battery status with ease. Additionally, this development board can function as a standard MCU board, providing user with the flexibility to program it using the provided API or develop their own programs. Nice, nice. I like this. Targeted industry or application area. This project simply specially targets low power application where monitoring current consumption and having flexibility in functionality are crucial. It caters to industries such as IoT, wearable device, portable electronics, and other battery powered systems where efficient battery charging and monitoring are essential requirement. Maybe we need to remove couple of things, but yes, nice, good, good. I forgot. I'm seeing my own stream and reacting there. Sorry. Problem or need addressed. I need addressed. Okay. The lack of integrated onboard charging and monitoring system in many existing MCU development boards pose a challenge for developers and users who require a comprehensive solution. This project aimed to address this need by providing an all-in-one solution that combines MCU development capabilities with battery charging and monitoring functionality. Nice one. Existing solution or products. While there are existing solutions and products in the market that offer similar functionality, they often come in different modification or separate modules. The MCU development board with battery monitoring and communication system features aim to provide a consolidate solution integrating essential features into a single development board. This streamlines the development process and enhance user experience by offering an unified platform for battery powered projects. By incorporating onboard battery charging, discharging battery charging, charge and discharge monitoring, and providing flexibility for user programming, this project aims to meet the requirement of developers and users seeking an efficient and versatile MCU development board with enhanced battery functionality. Let's go. That's very nice. But we will need to I guess I'll ask to uh, rewrite reframe background board with battery monitoring and consumption features stems from the need of comprehensive and versatile solution in the field or MC development traditional. Okay. Traditional MCU development board often lack integrated onboard battery charging and monitoring systems, limiting their functionality for low power application. To address this gap, this project aims to create a multi-purpose development board that combine the convenience of onboard battery charging and monitoring with the flexibility of standard MCU development platform. By incorporating features such as smart battery charger, charge and discharge monitoring, and onboard OLED display and communication capability, this project seeks to user-friendly and efficient solution for developer and users in various industries. The goal is to empower them with powerful and adaptable while enabling precise battery monitoring optimization. The project's objective is not limited to offering a standard product but also encompass. Wait a minute. Okay, I feel like this guy has will ask him to this. So we just need to use this thing, the ABC development board with battery monitoring and communication interface. See, I change the from to hmm, let me see. Project background with battery monitors which are emerged from the recognition of crucial need of advanced development board and MC development boards often lack efficient and integrated solution for and charging batteries, limiting this ability for low power application. To address this limitation, this project a versatile development board that combines the power of an MCU platform with compressor battery monitoring and charging functionality by focusing the battery, and it is a project seeks to provide for the ride the whole and okay, let's see compared to the previous one. Wait a minute. We just give him this info. I'm not sure. I am just gonna try this thing. Let's see. Okay. Main purpose, targeted industry and application, problem statement. So in introduction, we actually don't need project approach, target application, project background, problem statement, purpose, target function. This is what we need. I guess project objectives should be a different point. So we will just copy these things into a word, then try to optimize this later on. uh, but for now let's just copy, control all, control V, wait, control V, control all, small small small, 12, normal, Arial. Okay, what is the other one? We'll just take this as well just to get a structure of something. Okay, my bad. Okay, 12. Okay, later on, while moving forward, as today's was ideas, uh, in terms of ideas, I already had this idea planned. Okay, the idea was, sorry, okay, the idea was, for example, when we take any microcontroller device, okay, nowadays everything is been powered with battery, but this microcontroller development board doesn't feature a battery charging and battery monitoring system. Okay, sometimes we have to use an external modules, okay, to where we connect the battery and then we pass those connections to the microcontroller development board. I haven't seen or I was not able to find any of a development board which is capable of having this features built in. So I thought of which, because I am working a lot in this application of monitoring the battery, charging it, and I thought it would be better for me to make a simple device which does this functionality, but like for every time. Okay, but I also want a feature, okay, where if I want to change something, if I want to add anything extra, I just don't want to monitor the battery. I also want to drive motors. I want to drive something else. I should be able to do that. That's why it, from a specific use case, it evolved into a development board because it can be used as a development board, not just for that. Okay, so that's the basic idea. requirements, as we already saw, what are the requirements I have? I want an onboard charger. I want to monitor it, so there should be a sensor on it. Then I want a OLED display. I need an STM32 microcontroller. So why I am choosing STM32 microcontroller is because first thing, it is a 32-bit microcontroller which is very cheap compared to 80 mega 328p, which is approximately twice the amount of money I'm gonna pay for similar functionality, but lot more powerful than 80 mega 328p. That's why I choose it. And at mega 328p is an 8-bit microcontroller. So yes, that's why I chose a microcontroller which I already have, and I have a lot of, like, I have 10 or 15 pieces of that microcontroller. So, and I also have a development board, like a small knockoff version, or you can say Chinese board, which just has the microcontroller soldered onto it, and I can just use it to program it. The only downside I could say of STM32 is I can't use the UART or the communication interface to program the microcontroller. I can just use it to communicate to something else. Okay, I have to use a separate SWD programming tool. Sorry, an external string programmer which is meant to use to program this microcontrollers. Okay, so we will look on to how to do those things when we go forward. So uh, now we done with the idea. I explained you the idea. I explained you the requirements. My requirements, it can be different for you. Like, you can follow similar process. This first stream is just basic thing that I am just talking about all those things, different things, and what I want to do. Because if I would have just told you the idea from the beginning, then it would be a different thing. But it is very simple idea, to be completely honest. But now it's already open. Now we will start from the next stream. Probably I have decided to do it on weekends, but if I get any chance to do a live stream in between, like during the weekdays, or sometime like if I have a holiday or sometime during that time, I'll definitely drop a notification, or I'll just inform on to my Instagram stories. So make sure to subscribe to this channel and hit the notification bell icon, so you, when I go live or when I schedule a live event, you will be able to get the notification. Also, if you would be very what do you say, kind enough, you can go onto my Instagram profile and follow there. If I'm going live, I'll also drop a story notification or something to inform you guys that I'm going live. But as for today, I guess I am gonna be done, I think, because I don't think so, like, moving any further would be a good idea for me personally, because this is the first time I'm talking for so long. I'm having a little bit rash throat now. But yeah, first day done. Okay, idea got a pretty much understanding, I guess. Few of the topics you might haven't understand, like things from my idea, we will discuss it moving forward more in detail, so it will get, you will get a clear idea. Second, the requirement, I guess the requirement will change depending on how we start developing it. Because sometimes what happens in electronics is, for example, I am just planning to add one temperature sensor, but when we actually start developing, and as the system evolves, we come to know that we might require additional things. So that's that things is gonna just keep increasing as we move further by each and every step. So yeah, requirements done as for now, but we might need to add a lot of things later on moving forward. Third was, what was it? Just a second. Research. Doing research. We did some research on how using ChatGPT. We used ChatGPT, so asked him to do write down things. I will be. I have copied this information, and I will sit and see how it is. And in the next session, before we actually start working on things, we will go through this document. We will see and make a final version of it, and we will keep doing this on every time, like adding small sections every time, so we don't lose the track of why this project is, or keep adding things. Okay. And in this way it will be also good to document. And when if someone is on my website and he or she wants to use my uh, product, or like I will be selling this as well, I hope so. So if he or she bought this from Amazon or somewhere else, the person needs to go to the website and it will give him the proper details of each and everything. So we need to also document it properly, so on the later state I won't face any issues. I won't struggle just to document. Okay. So guys, thank you for joining my live stream. I hope you guys understood, or if you have any question, if you didn't understand anything, make sure to question me. Thanks for Siddhant who joined me and he was able to question and ask me and help me out as well, explaining few things in a better way. He's my friend, by the way, so I'm glad he joined me. And the other people who joined and watched my live stream, or who's gonna be watching later on, thanks for watching, guys. I hope you had a lovely day, and if it's evening, a wonderful evening. See you guys in the next one. Please like, share, comment, and make sure to subscribe and hit the notification bell icon. You will get the notification when I come live next time. All right. See ya. Bye.